Hi guys, okay, today let's talk about doubly linked list. And disclaimer, this is just a way for me to reinforce what I'm trying to learn. And right now, I try to learn about doubly linked list, and of course, I'm making a video about it so I can explain it and to enforce it, well, on my brain. But yeah, let's learn about doubly linked list. Now, so first, for us to know what a doubly linked list is, we need to know what a linked list is. Well, a list is pretty much an array. So we have a list of items. There we go. From A to, let's say, A, B, C, D, E. From A to E, we have a list, an array of items, you can call it. And the linked list is pretty much a list wherein everything is linked together. And for a linked list, we have a head, which is the starting point of this list or array, and a tail, which is the end point of a list. So for this to be linked, we just need to, well, from the head, from the beginning, we need to point, or we need this to actually link onto the tail or the end. And to do that, we just need to link towards the next item of the list from head to the next item before it, and then the next item for this one, for example, B, and then the next one, suppose C, and the next one from C would be D, and then now D would point to E. My drawing really is bad. Wait, let me try to make this better. Okay, there we go. This is much better now. Anyway, so this is the head. And this, at the end of the list, would be the tail. Okay? So this is what we call a linked list. Pretty much a list rather, that is linked together. For example, here A, in let's say in an implementation, we will have A, so an object. The value of A should be item, let's say I, and then the next node or next item in the list would be inside of this next key. So let's just say next item would be the item letter B right here. And then this would be the same for letter B, wherein the value of B, so A, let's say A equals this one, and then B. Okay, that's a bad looking B right there. B equals to value I, and next would be, of course, letter C. Okay, like so. And then this will go on until when we reach E. So E, the value of that would be, let's say, J. And then the next item from E would be undefined because it does not exist since E is the tail. Okay, so let's just say it's null instead of undefined actually. Excuse me. No, like so. Okay, all right. So that is pretty much what a linked list is. You know what? Let's actually try to implement this first, this linked list. So let me try to remove this and change this to, well, linked list. Linked. Wow, the best handwriting ever. There we go. So linked list is pretty much a node or an object wherein it contains its value and then a pointer to the node or object that is right next to it. Okay? And of course, all of this is contained inside a container or a list. So to do that, let's go to our code editor. Okay? So now we are our, okay, excuse me. So now we are at the folder, the structures. Let's just make a file called linked list. And of course, we're going to use JavaScript for this, because why not? Let's open a terminal. Okay. All right. So for a linked list, well, it's a list that is linked together from our example in a whiteboard, like here. Okay. So we need a way to implement this list over here. And to do that, since we are referencing a head and a tail, we can use an object. So let's just say class linked list. So a class is pretty much syntactic sugar for prototypes, and I will not dig deep about it. Let's say a class is pretty much like an object. Wherein if we instantiate a new linked list, it will look like this, and then it will have keys based on what you provide inside the constructor. So for example, we provide the key of this that head. Right? We will then have head here, which is undefined. On the first call, of course. And it would be the same for tail. Find. And we will have tail undefined, like so. Okay? Alright. Okay, let's go through this together and make some mistakes along the way. Alright, anyway, let's see. So, what operations do we want here for a list? Well, we want to be able to append an item. So let's just say append and then item. Okay. Okay, to append an item, well, we need to insert this item at the very end of the list since it's appending. Okay. All right. One more thing is we need to actually keep track of the length of this list. So this is for bookkeeping to just have a basis of, oh, what's the length currently? Because we are not using an array here. We're using objects. And since we cannot get the length of objects, then we need to bookkeep the current length that we have for this list, or how many items there is in the list currently. Okay. So in here, since we're going to append, we just say this is the length. We'll increment it by 1. So from 0, it will now be 1. Okay. On the first append, of course. So this statement right here can also be equals to this dot length is 1. So let's just do it this way, just for to make it explicit, I guess. Okay. Okay. So if we're going to append, then we need to know if a tail exists or not. Since basically we're going to append this to a tail. Okay, so if the tail is at the very end, for example, in this example, we have a tail, letter E, we will append, let's say, the node, letter F. So to do that, we need to know if this tail exists or not. So we'll just say if this dot tail exists, okay? Then we can do the append operation. But if it does not exist, then let's go back to the editor. If it does not exist, then we can just reference the head of this list and the tail of this list equal to this item. Okay, so first let's just say const node is equals to the value of that node item, like so. And then we can just say, what was it again? This dot head is equals to node this, and this dot tail is equals to node. Okay. Okay. So since we're going to append, then we just need to add this node to the tail or to the very end of the list. And since the very end of the list is considered to be the tail of the list, they will just say this.tail is equals to the node. That's it. And of course, we need the previous tail. For example, in this example in the whiteboard, we have letter E, and if we add F, the new tail will be F. However, we need E to point to F. So we just say this.tail dot next is equals to node. And then the new tail would be equals to the node right here. Okay. So just a note is that this node right here has a structure of distributed. That's a structure of like this. You have a value, say 1 or 0, and then the next will be an object again, and the previous as well. So it can be an object or undefined. This one same for next. So this is pretty much the structure at the basic level of this list right here. Oh, I'm actually not showing it. Oops. Okay, there we go. Not used to changing stuff, but anyway, here we go. So this is the, based on my understanding, the structure of a list for this guy, or for a linked list. Okay. So now that we've done the appending, let's do the prepend. Prepend item. So we're just going to add this dot length equals to this dot length plus 1. Since we're going to add an item, but at the very first or at the very start of the list. Okay, so the logic is pretty much the same. So we'll just say if, okay, first let's declare the node actually. So const node is equals to, well, the key of value would be the item. Then we'll check if the head exists. Then that is when we can do this prepend operation. But if it does not exist, then we can just say this dot head is equals to node, and this dot tail is equals to node. So pretty much the same thing. Okay. And since we're actually repeating this logic right here, you can just say first, what can we call this? First item. Maybe initialize. Then we'll just say item, then const node equals to value item. And then this dot head is equals to node, this dot tail equals to node, like so. Then we can just call this dot initialize item, and the same thing down here. Right? Okay, so somewhat the same logic here, but this time it's a little different. So we'll say that since we're appending, or rather prepending, that means we're inserting at the very beginning. So if I show you on the whiteboard, so from A, the head, and for example, we're going to prepend, let's say letter Z, right before A. Okay, I should actually grab my marker here. Okay, so from A, okay, let's say we're going to add letter Z right here on this list. So that means this will be the new head, okay? New head. Okay, that is the best handwriting ever. And then, of course, since this will be the new head, we need a way to point this new head to letter A. Because this was the previous head before. So we'll just say Z, okay, point to A. And that's it. So let's try this out. Oops. Okay, so we want the head Hmm. This dot head dot red. Oh, that's correct. Okay, so we want the head to be equals to node. Okay. So this one would be node dot next. So the next item of this current node, which will be the new head, would be equal to the current head before we do this operation. Okay, there we go. So what we're doing here is that since node has the structure of this right here, or not that, here, next and previous, we'll just say that the value of node.next is equals to the head. Because based on the whiteboard here, okay, wait, let me move. Come on. Here, letter Z, and the node would be letter Z here because we are prepending. We're saying that Z, let's point the next key value of Z equal to A, which is the head or the previous head. And then now we're just going to assign the new head to the list equal to letter Z. So that's it. Okay. And now let's go to the insert at. Wait, will this work actually? Insert at. Insert at this index. Yeah, let's try if it works or not. So insert at, we need to know at which index do we want to insert this, and then what item do we want to insert. There we go. So first, let's actually bookkeep because we don't want to go over the board of the list. So let's say if the index is greater than the length of the index, then we just want to return undefined or throw an error, I guess. Throw error. We cannot insert past the length of the list. Current length is, then we just show the length like so. There we go. Okay. Since it will actually make this more complicated if we try to insert the item past the current length of this list. We can, I guess, put some dummy ones, dummy data, but it will make it more complicated. So let's do the gist of the list. Okay. So if we're going to insert, first we'll check if index is equals to 0. So that means at the very beginning of the list. So we'll just do the operation prepend. Since it already exists, we don't need to repeat the logic. Let me just return. Then the same for if the index is equals to this dot length, like so. Then we just say append item the return. Okay. So now let's do the logic of inserting at a specific index. So just like in arrays, I guess, why don't we do this one by one? So we're going to start, well, either at the very beginning or at the very end. But in this case, since this is a linked list, the only way we can traverse through the list is at the beginning, at the head. Okay, we cannot start at the tail because we are only pointing to each node or to each data or value for each item in one direction, that is from head to tail. So we can just say let current node is equal to this that head, since we're going to start at this head, at the head. Okay, let me just bring that back, the editor. There we go. And then we will go for a for loop for let I equals 0 as long as I, or as long as current node exists, and I is less than index plus I. Okay. Is it less than index or less than equal? Okay, let's try this first. Okay, anyway, so in this loop, we're just going to move from one node to the next. So, for example, in here, from head, we're going to move to A. So to do that, we'll just say current node will be equals to current node dot next. There we go. It's still a sense, or in this case, it's like GitHub pilot, but it's tab by. Oh, I don't care. Anyway, it's what you call autocomplete. Oh, you didn't actually see it. Wait, like here, I had this auto-completed, but anyway, that doesn't matter. Let's go back to the whiteboard. Okay, so in here, from head, we need to assign the current node that we're traversing equal to A. So we'll just say current node would be equals to the next value, that is the next value of the head, which is letter Z. So where is this node, letter Z, pointing towards? Well, letter A. So that means our current node on the next iteration would be equals to A. So that is what this implementation we have in the for loop is say. Okay. Okay. That's why we say less than the index that we're looking for. Okay. Because if, for example, okay, wait, this is pretty hard. Oh, wait, anyway. If, for example, you are traversing, okay, you're trying to insert at letter B. So insert at B. The index for this would be 2. So 0, 1, 2. Okay. So from Z, we'll say at the first iteration, current node, C, current node, be equals to A right here. Okay, that is the first iteration. Then the next iteration, we'll say that A will be equals to A dot next B. Okay, and since our index we're looking for is 2, 1 is less than 2, but 2 at the next iteration is not less than 2. So we stop right there, and now the current node is letter B. Okay. So in here, we just perform the logic of inserting an item in this list or in this index. How can we do it? Current node. Oh wait, is it current? Do we need to get letter B or is it letter A? We actually need to get letter A here. Yeah. We need to get letter A. So that will be index minus 1. Why is that? Well, if we go back to the whiteboard, yes, go down here. For example, we have A. Is it visible? A. Okay, good. We have A, B, and C, and D. Okay. And let's say this is our head. So the head. And we want to insert at letter A. Okay. And the index of this would be 2. And since just like earlier we have from 0, so current node would be equals to B. So at 0, at the first iteration 0, current would be equals to letter B since A is pointing to B. Okay. And then at the next iteration, which we put 1, B equals to C. But of course, this will not be applicable anymore because we said index minus 1. And since index minus 1, 2 minus 1 is 1, and 1 is not less than 1, then we stop right there. So that means the current node that we are at would be letter B. So the 1, like so. Why is that? Well, let's say just that at this index of 2, we want to insert the item of letter E. Okay? So if we stop right here, we can just say B or current node. We can say at this point, when we reach letter B, so current node is B, right? So current node dot next would now be equal instead of C, it will now be equal to letter E. Then of course, letter E, that next will be equal to letter C. Okay? So do we need to actually keep track of two of them? But yeah, this is the pretty much the implementation here. How can we get C though? Wait, let me check. Interesting. Square note at next. I think we need to get two, right? We need to get two with a B and C. Okay, let's try this one first. Const node is equals to an object or the value of item. Then node dot next, or rather current node dot next would be equals to node. Oh, okay, correct. Wait. So node dot next will be equals to current node dot next. Okay, so this is correct. Okay, good. And that's it. So what we're doing here is pretty much the explanation on the whiteboard. If I just change it right here. Okay, so current node dot next be equals to the node that we want to insert. And then the next value for the node that we want to insert would be equals to, well, the previous node that this one is pointing towards. Okay, so let's say we have, I need to make this smaller actually. A, B, C, D. So let's say this is pointing to C, then we want to insert E. Okay, so what we're doing here is pretty much, okay, I want E, the node to be inserted at, the next value for E of E would be equals to C. So we'll just say E is equals to C. So current node, or rather node that next, which is E, would be equals to whatever node this current node, which is B, is pointing towards to, which is letter C. Okay? And then after that, after pointing towards C, this node, letter B, will now point to this node right here. Okay? Okay. Good. Okay. What else do we need to implement? Need to implement the remove, right? Yeah. Okay, let's do that. So let's say remove. Excuse me. And what item do you want to remove? Like so. All right. Did we actually bookkeep here? No, we did not. Okay, so down here we need to bookkeep. This dot length plus equals to this dot length is 1, like so. Okay. So remove is, we're pretty much going to do a linear search here, although I think it will be better to have some kind of, well, it will be more complicated, but like hash maps. I'm not sure what it is yet. I'm still going to study it, but yeah. Let's do a linear search, or pretty much just traversing through the list. So to do that, we'll do what we did up here, but somewhat different, right? Yeah, somewhat different. So we'll just say let current node is equals to this dot head. Then we're just going to traverse throughout the list. Let I equals 0. I should say index equals 0. As long as index is less than, or as long as current node exists and index is less than this dot length, we just increment index by 1. Okay. And then just like earlier, we just say current node dot, or current node equals to current node dot next, like so. And we need to have a condition here, just like in linear search. Wherein if current node dot value is equals to item, we just break out of this loop. Excuse me. Because we want to break out of this loop, that means we have found the item, and we are going to remove that from the list, or we're going to remove that node from the list, okay? And in here, after traversing throughout the list, we'll just say if current node does not exist, since at since at the tail of this list, tail that next would be undefined because it does not exist. So we'll say if there's no current node, just want to return undefined. Okay. How do we implement this removal? Well, we are at the current node that we want to remove. So okay, let's go back to the whiteboard actually. Whiteboard, here we go. Okay. So let's say we're trying to remove something from okay A, B, C, D. What's happened? There we go. Let's say we're trying to remove letter C. So just say delete or del. There we go. So current node from head A to C, since the value of C would be equal to whatever we're trying to delete. Okay. So to delete that, we need to break off the connection. So first, I guess we can do is hmm, ah wait, I think it will be the same as what we did during the insertion because we need to have access to letter B here. Okay, okay. Let's try. Let's remake that. Where's my code editor? Oh, where did I put it? Wait. Okay, there we go. I found it. Okay. Anyway, so it's actually the same. No, current node index less than. Oh no. Okay, this is correct. This loop is correct. So once we reach that item. Yeah. Okay. So we need to access letter B in the example of the whiteboard. So that would be the item that is right before the current node that we're trying to remove. Right. So I guess we will do another loop here, wherein let index equals 0 as long as index. Wait, do we really need to? Hmm. Can't we just, yeah, since we don't have reference to the previous value. Wait, but maybe, just maybe, print, yeah, we can't. So we need to look through this again. Okay, so let previous node equals to, so we'll just do two iterations here, I guess. One to find the current node that we want to delete, and the second would be the previous node that we want to delete. So as long as previous node exists and index is less than mm, this dot length. Oh no, how can we find this? Interesting. Wait, let me think about it deeply. Ah, okay, I see. What we can do is we can do a while loop. So we'll have a index here. Okay. Oh, I think it's the same as a for loop. Yeah, it's the same as a for loop. Okay, this is the for loop. Let I equal 0, or index, I guess, to make it more clear. As long as previous node exists and index is less than this length plus plus index. Excuse me. Okay. We'll check if current node is equals to previous node dot next. Okay. And I think we should check the value. Okay. So the value of the previous node dot next. So okay. So this is how we can find the previous node. So we'll just say break out of this loop. But if it's not equal, then we just continue on. Okay. I think there's a better implementation for this, but right now let's do it this way. Okay. Now what do we know? So now we need to point previous node dot next equal to the node that this current node is pointing towards. There we go. And that's pretty much it. I guess we can return current node. Okay. So it's pretty much the same as what we had in the whiteboard. So once we found letter C and letter B, so letter B is the previous node and C is the current node. So we need previous node to point towards to whatever node this current node is pointing towards, which is letter D. Okay, so that's it. Okay, let's try one more thing, which is the um remove at. So remove at what specific index? Okay, do we need to get this kernel node? Nah, it's unique. Yeah, we can't abstract it. Oh well. Anyway, so the remove at a specific index. Okay, and of course, if index is greater than this dot length. Oh wait, I forgot to bookkeep once again. Since we're removing an item, we need to reduce the length. So where can we reduce that? Down here. This dot length is equals to this dot length minus 1, like so. And here, if index that we're trying to remove is greater than this dot length, we just throw a new error, I guess. Cannot remove an item past the list length. Current length is plus this dot length. Okay. All right. So in here, excuse me, we just have the same logic for this one, right? Let's try. So let current node equals to this dot head for let index equals to 0 as long as current, excuse me, node exists and index is, oh, I try to use I instead of index. At I equals 0. So long as I is less than this dot length, or this rather I is less than index, okay, minus 1 just before the item that we're trying to delete. Okay. Going all over the place now. There we go. We just assign current node is equals to current node dot next, like so. Then we'll just say if current node does not exist, then we just return undefined. All right. So now let's do the logic here. Since current node, for example, if we're trying to delete, for example, we're trying to delete from A, B, and C, and D, we're trying to delete letter B this time. So delete letter B. So we'll just loop through this. So this dot head. So let I equals 0 as long as I is less than index. So 0 and then 1. We're going to change current node equals to current node at next. So current node is equals to B. Ah, wait, index minus 1, 0. Okay. So that means our current node would be letter A right here. So this is okay. So since index minus 1 is our if statement here, as long as I is less than index minus 1, so index is 1, we're trying to delete the index 1, which is the node letter B. 1 minus 1 is 0. So that means we're not going to perform the loop. And the current node would be equals to the head, which is A. Then we just need to have a statement wherein this A right here, instead of pointing to B, we need this to point to letter C, because this is the node where B is pointing at. So we'll just say current node dot next will be equals to current node dot next dot next. Is this correct? Current node is equals to current node dot next dot next. Let me check. Yep. Okay. So what we're saying is that the new value for the current node, that next, which is A, will be equals to the next value of letter B right here. Okay, let's try this out actually and see if it works. Okay. Next is equals to next. Okay, now let's try to test this out. So first, let's see if appending will work. So list that append 1, list dot append 2, console.log list, like so, and check it out. Node. All right, I forgot one more thing, which is to subtract the length by 1, like so. Save that, and now run this node linked list. So for this to run, and as you can see, it's working. The length is 2 because we have two values, which is 1 and 2. And here, as you can see, head is pointing, or rather head is equals to this value 1. And this node right here, this overall object, as you can see, is encapsulating this right here, value 2. And of course, this is the tail because this is the end. Okay, so let's try to is that prepend 3. So in this logic, 3 should be the first value now when we console log. Or 3 should be the head here. Okay, there we go. 3 is the head. The next would be 1, the middle one right here, because we prepended 3 to 1. Then the next object would be 2, which would be right here, the tail. Okay? So let's try to remove let 2 now. Is that remove 2. See what we get. We should get 2 right here. Or we should remove 2. There we go. We remove 2. Oh, wait. Okay, we have a problem. The tail is equals to 2, which should not be the case. Okay, let's go back to remove. Aha, we forgot one more thing. This dot tail equals to current node dot next. Right? Let's try this out once again. Node linked list. Uh-huh. Hmm. Current node. Maybe this should be above. Hmm. The tail should be value 1 here. Previous node. Hmm. No, no, no. The tail should be 1. Ah, I think current node. Okay, okay. Okay, that's my bad. Should be current node. Oops. What? Interesting. Hmm. Let's see. There's no current node. There we go. Okay. All right. Hmm. Is the tail with the previous node? Previous node is 1. Is for deleting number 2. Okay. So in here we're appending 1 and then 2, and then 3. So now 1 would be at the middle. Then we're trying to remove 2, which is at the very last part. Okay. So if I remove this, it will look like the one earlier. So I need to save this actually. There we go. So now the tail here is 2 right here. So if we remove 2, that means the new tail would be 1. And the next value for this 1 right here would be undefined. There we go. I forgot to change the tail on the remove function. Yeah. Okay. That's good. Okay, let's try the remove at now. So let's say we want to append another value. So let's say we want to insert at. So after removing, we have the length of 2. So let's say we want to insert at 1. Then the item would be 10. Okay. Node length list. So that means 10 should be in the middle now. Then the 1 would be the tail. Okay, there we go. Now the tail is 1 right here. That's good. Then now let's try to insert at 1 again. And the value would be 12. So now 10 would be right after 12. Then 12 would be right after 3, which is the head. Try this. Okay, very nice. And then if you want to remove at 1, we should remove 12 here. So now 12 will now be equal to 10 in the console. There we go. Okay, very nice, very nice. So that's pretty much it. That is the overall thing of linked lists, wherein we can remove, append, prepend, insert, and remove at a specific index. And this can definitely be better. And for that, I mean the for loops. Hmm. Maybe we can extract this. Can we? Um, Where's the one? Yeah, this one. We can extract this. You can just say so. Then extract this. You can just return current load. And over here, you can just say const current node is equal to get this dot get previous node at index, like so. Then the same one above, wherein we are using this logic of a for loop, which is up here. Yeah. So, and now let's see if this still works or not. There we go. We still have the same value from earlier. Okay, should I talk about double linked list now? I think this is enough for a video. What did I say doubly linked list right off the bat? Okay, I think this is it for now. Wow, pretty cool. I actually planned to talk about doubly linked list, but here we go. It's pretty amazing actually. Damn. But yeah, as you can see, it's only pointing to one node or one value. There's no previous, and previous is a doubly linked list. Okay, I think that's it. Anyway, so that's how we can pretty much use objects to our advantage, or classes, to make a list of data, wherein each data is pointed to a new data, like so, and then we can delete and remove, blah blah blah. And I think you need to do some kind of garbage collection as well, but in JavaScript you don't need to worry about it, because let's say at here when we remove, where where does it go? Since it does, since for example, the console, right here we're trying to remove at the index 1, which should be 12, and now since 12, the new pointer of 3, which is next, would be 10, and then yeah, that's it. 3 will now point to 10. That means 12 is not pointing. That means there is nothing that is pointing towards 12 now in this list. So it's considered as garbage. So it either needs to be collected or it needs to be reused in the future. So that's actually something that I'd love to learn as well in the future. But for now, this is how we can implement a linked list. Okay? And yeah, that's all. Wow. Okay, I don't know why I talked about doubly linked lists at the introduction, but there it is. Anyway, thank you for watching, and I hope you enjoyed. And I hope you learned something, and good luck on your development journey, and happy learning. Bye bye.